Welcome to Knowledge Base. In today's video, we are going to discuss the concept of relative motion. First of all, what is motion? Motion is the change in position of an object. When that change in position is described with respect to a reference point, then we are talking about relative motion. So, relative motion is the motion of a body with respect to a reference point. We are going to describe different concepts to explain relative motion. The first one is this. If we have an object A moving in this direction and the motion of A is observed by an observer B, then we can describe relative motion as this. We can say the relative motion of A, because A is the one moving, with respect to an observer B, is the motion of A as observed by B. In other words, relative motion of A is how B sees the motion of A. That is what we mean by motion of A with respect to B. For instance, if A is moving at a speed of 100 km per hour, while the observer B is standing in this position, the motion of A as observed by B, or the motion of A with respect to B, is simply 100 km per hour. However, let's assume that the observer B is also moving at 10 km per hour. Because the observer is moving at a slower speed than A, he will see A to be moving at a speed less of 10 km per hour because he's equally moving, which means that observer B will see A to be moving at about 90 km per hour because he is also moving. So he just takes the difference of the speed and that tells him the speed at which A is moving. So if A was moving at 100 and B starts moving at 10, B we observe that A is moving at about 90 km per hour. That is the concept of relative motion. It is the way B sees A with respect to itself. That is the relative motion we're talking about. So in this scenario, we can say that the relative velocity of A with respect to the observer B is equal to 10 minus 100 minus 10, and that is 90 km per hour. It is simply how B sees the motion of A. That is the concept of relative velocity. Let's look at another scenario. Two buses, bus A and B, driving along a road, and bus B tries to overtake bus A, or it is overtaking bus A. You observe that if you are in bus A, you will see B to be driving past you very slowly or at a slow speed, even though both cars are driving with a fast speed. But because B is overtaking a moving car A, the passengers or the people sitting in A will see B to be moving slowly past them, as if it is not really fast moving bus, or it's not a really fast moving bus. The reason is because B is moving and A is equally moving. Let's put figures to it to understand better. Let's assume B is moving at 110 km per hour as it overtakes A, while A is moving at 100 km per hour. You observe that you will agree with me that both speeds are really high speeds. But the passenger in A moving at 100 would see B to be driving past them at a very small speed of 10 km per hour, which is the difference. So it is often observed that when you are seeing a bus overtaking your own bus, the overtaking bus seems to be moving at a slow speed. So A sees B, we can say that bus A sees bus B to be driving at just 10 km per hour, which is the difference in speed. This is the concept of relative motion. So we can say the speed of B relative to A is 10 km per hour. Lastly, if you are seated in a bus and you look at the floor of the bus, you will observe that the bus, or it will appear as though the bus is not moving. The reason is that you are moving at the same speed as the bus. So it appears as though the bus is not moving because both of you have the same speed that cancels each other. So we can conclude that when a person sitting inside a moving bus looks at the bus floor, the bus appears to be stationary. This is because the relative velocity of the bus with respect to the person is zero. In our subsequent video, we will discuss with further examples and this time calculations of the concept of relative motion. I hope you enjoyed this video. Thank you very much for watching and see you in our next video. Bye.